So this is a sinusoidal wave. The Vm is amplitude and angular frequency times t. You can play with it by vary the time. You can use Python to vary the time, or omega t here from 0 to 100 or something, and change the amplitude to see how it's worked. So move fast forward. So leading and lagging. So let's look at this figure 10.2. The original wave is a sine wave, which is since the green light, and the red line is a signal that add a phase into it, and we say that the red line is leading the green line. So how do we understand this conceptually? So first, let's ignore the left hand side and just focus on the right hand side. As you see on the right hand side, the red line reached its peak faster compared to the green line. So we say that the side of omega t plus theta is leading the original one. And we can also say that the original is lagging by a theta phase compared to the red line. So move forward. So in order to see like the leading phase or lagging phase, we need to write them in either sine wave or cosine wave so that we can compare. For example, this one and this one is comparable, but basically they are the same because pi over 6 30 degrees. They need to have positive amplitude, and they also have to have the same frequency. That means this part should be the same. So how do we make sure they are in either cosine and cosine? So we can use these properties, and to convert to positive amplitude, we can also use these things. Alright, so this is an example. So first we have V1 is a cosine signal of leading 10, and we want to compare it with this signal. So we have to convert cosine to sine. How do we do it? So we can use this equation here by adding 90 degree, and also notice that the sine here is swap for sine to cosine. So we add 90 and we have 5t plus 100 compared to minus 30. And then I think this is the easiest way to determine leading or lagging by plotting them on a circle like this. So you can plot V1 first by leading 100 degree, and V2 minus 30. So now if we want to determine how many degree that V1 leading V2, then so here is so if we say V1 leading V2, then we start from V2. So for example, V1 leading V2, then we start from here and we measure the distance from here to here. So it's leading 130 degree, right? What about V1 lagging V2? That's possible as well. Then we start from where? Think about it. So we start from V1. So let's see. So we start from V1. We draw a line here, and this is 260 minus 30 is 230. But what about the side here? So because we go both of them going counterclockwise, so they are positive counterclockwise. And if we go clockwise, then side here gonna be negative. Let's start with this example. So I1 lag V1, so lagging, right? And then we start from the first one. Leading, we'll start from the one. So okay, I1 lag V1, then V1 equal this. So this is cosine minus 40. Alright, let's do I just draw a circle here because I know that they are in the same positive amplitude, same frequency, just different phase. So minus 40 for V1. What about I1? I1 is plus 20. Okay, so what is the angle? Is it lagging? So we start from the first one, which is I1, and then we go to V1. So the distance between them is 60 degree. because it is clockwise, so this should be negative. So counterclockwise positive, clockwise is negative. So with these steps you can work with any problem. So let's try with an example B. We have a different sinusoidal wave type, so we gotta convert sine to cosine here. So how do we convert sine to cosine? Minus 70 minus 90 is minus 160, right? And then we have minus 40 here, minus 90 minus 160, so around here this is I1, so minus 160. What is the distance? Same thing, I1 like V1. So we start from I1 here. So the distance between them is 120 because it is clockwise, so it's positive. And then I think you can work on other problem. Just remember, we say V1 leading V2, and when we draw the circle here, we started from V2 or V1 lagging, then we start from V1. If you want to do reverse way, like clockwise, you want to be positive, then I think we can pick V1 here, and it's the same thing, just reverse the direction. So this is a systematic way for you to easier to work with.